All right, guys, let me just share my screen. All right. So here we are. I just wanted to just do this last little section for you. Oh. So we've seen all of that. That. I think we left off here. Yeah. Right. So this is where we left off. So when acetylcholine binds to the acetylcholine receptors, it allows sodium ions to enter the muscle cell, and that kicks off an action potential. And as you can see here, I said that the action potential goes all the way along the muscle cell. But not only does the action potential go all the way along the muscle cell, the action potential goes through the muscle cell. Look, how the hell does this happen? Well, look at this. This blue stuff here, that is the plasma membrane of the muscle cell. And look, it's got tunnels that go through the muscle cell. So technically, if I was small enough, okay, I could go through those tunnels and end up at the other side of the muscle cell. So the action potential goes from the neuron to the muscle cell, along the muscle cell, and through the muscle cell. Now, these cave systems, so these tubes or caves, are called the T-tubules, okay? So they go through the muscle cell and they make a cave out of plasma membranes. It's a plasma membrane cave. Yeah. Right. So what happens after that? Let me just move myself here. Okay. So it goes through the T-tubules. Oh, wait a second. What have I done here? Oh. Oops, go back a step. Here we go. I just lost my mouse there for a second. Here is the muscle cell. It's also called a muscle fiber. And see here, these are the openings to the caves. Yeah. So the caves are the transverse tubules. And the caves themselves are in this picture. They are the purple ones. Okay. See there? So these are all the holes going into the purple caves that you end up basically at the other side of the muscle cell without ever going into the muscle cell. Right? Now, what happens is that when the action potential goes through the muscle cell and down the caves, this causes something very special to happen. Can you see next to the caves that there are like blue, it's blue stuff? It's like a net. Yeah. So in that blue structure here, we actually have calcium stored in there. So when the action potential goes through the muscle cell via the caves, the calcium that sit in this blue structure actually comes out. Okay, so the blue structure is like a calcium storage area. So when the action potential comes down, calcium moves from the storage area. See here? Here is the plasma membrane of the muscle cell. Here is the T-tubule, which is the cave system made out of plasma membrane. And when it goes through here, calcium that's in this blue area moves from inside to outside in this area here. Here we go. Let's watch it. Yay, look at them go. Calcium ions. There we go. Oh, that one was a bit wobbly. There we go. So the calcium ends up in or amongst something called a myofibril. So remember when I said that a muscle cell was like a cylinder? Well, a myofibril is little cylinders that are inside the muscle cell. So can you count here how many myofibrils we have in this muscle cell? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So a myofibril is a little cylinder that lives inside the muscle cell, which is itself a cylinder shape. Okay, so I think that was the last bit of the recording. And let me just have a look here. Let's just finish this part of the story about looking at what we have learnt thus far. You have an action potential. Oh, there you go. Right, so we need to get from the neuron to the myofibril. Here we go. This is little me again. Down the T tubules, and then calcium moves out. And remember, we are there. So we are left off this story. We have finished off this story, topic 6, part 2A, in the myofibril, where we've just dumped a whole bunch of calcium. Okay, so that should provide the missing piece. Thanks, guys.